All right, this is the second video on 5.1. Okay, I'm doing problem number 12. So we need to show that whether this transformation from a third degree polynomial to a constant, R is just a constant. So polynomial is this one, and then if I use the transformation and just get the constant, right? So is this a linear transformation or not? But for the time's sake, I just wrote down this one. Okay, it'll be quicker here. So I mean, if you need to pause anytime, you do that, please. Determine whether this is a linear transformation or not. Right. So I chose two polynomials. This one is a polynomial cube, square, t, and then constant. And the same way, a2 is a2, b2, c2, and d2 are the coefficient of this polynomial. These are the polynomial in 2, and then k is like it's a constant. So there's a c is already involved. That's why I put it. K is a constant, right? So again, constants times one polynomial. So I distribute this constant inside here. And then after you distribute that, you see that the output is a plus b, right? A plus b over here. So a is the coefficient of t cubed. So in this time, the coefficient of t cubed is ka1. And the coefficient of t square is kb2, so kb2. And then I just put out the k, and then a1 plus b1. And again, a1 plus b1 means that's a transformation of, I'm going backwards now, right? So k times transformation of this polynomial, and which satisfies the first condition. All right, the second condition is I have two polynomials. I'm going to add these two polynomials and take a transformation. So you combine this one. So I combine the cubic terms, I combine the square terms, combine the t's terms, and then constant, all right? But the output of this whole thing is, again, coefficient of cube term plus coefficient of square term, right? Just add it. But I can rearrange this one, a1 plus b1, I put there, a2 plus b2 I put together. But remember that a1 plus b1 that means the transformation of this polynomial. a2 plus b2 is a transformation of this polynomial. So that's why it satisfies both properties. So that's why it's a linear transformation. Okay, I think this is pretty short. I think you can pause it and look at it, right? So let me do another problem, one more problem here. 14. So the transformation is from matrix, 2 by 2 matrix, to a constant again. The special constant is, this is like a determinant, right? So determinant. So this transformation, when you do the transformation, what happened is that change into a constant number, which is the determinant of that matrix, okay? Again, first let's do the first property. So k times this matrix is like a k you can multiply inside. That's this is like a constant. It goes inside and multiply each term. And then now the property, the transformation says that this is exactly same as the determinant of each, like a determinant of that matrix, which is that. Now you need to go back again and look at the determinant. What is the determinant of k times a? All right. The properties of determinant says that k times a is like k, if there's a constant there multiplying to each term in k, a, you can pull out that constant, but you have to power n, because n is a number, n is the size of the matrix, right? So in this case, we have to put k is not enough. You have to put k square, all right? And then times your determinant, that's exactly same as this one, all right? So you just cannot get just a k times this one. You cannot. That's why it's not a linear transformation. All right, just to explain this one here, I give you one example, right? So let's see, A is your matrix this. So determinant is 2, you see that? And then if I multiply by 2 to this matrix, that becomes this, right? So the determinant of this one is 8. Look at that. This is not 2 times 2. 2 is like you just multiply by 2 to A, right? 2 times 2 should be 4, not 8. Is that? So that's why when you cannot just pull out this k out. So you have to pull out this k. So you have a ka, determinant is exactly same as k square and determinant of a. So in this case, k is 2 square, and then determinant of a is determinant of a, so that's a 4 times 2, which is 8, and that matches with this one. I don't know, is it clear or not? Just pause it and look at this one more time. So that 2 example, I'm going to stop here.